Okay, BMIS 270, part 3, and we're just finishing up the database chapter in Management Information Systems. So I guess as we're looking at this, remember that we have entities, attributes, and then keys. Keys is something new. So within an entity, we have this particular table is probably, gosh, what would it be? Employees, I guess. So that would be an employee. An employee number, okay, which identifies an employee. A good example of an employee number might be a social security number, although we don't use that. A student ID number is another good example of something unique that identifies you as a student specifically. So we have attributes, we have field or last names, first names, hire dates, department numbers, and so on. Okay, so these are records going across, and again columns going down. Now the real thing here is that this is a primary key. So a primary key is a particular key that identifies a row specifically. Now in the next picture, what we end up with, and I'll look to the larger screen on my left side, that you have a series of tables. You have a project table, department table, and a manager table. So these are all within the same database, but they're separate entities. They're separate pieces. Now they're tied together though. Project number is a primary key for this particular table. Now department number is a primary key for the department table, and SSN is a primary key for the manager table. Now these all have to be tied together in some way. So the department number is a primary key, and it is tied to a department number in the project table, and it's a foreign key. So department number in the project table is a foreign key. Now also in a similar fashion, SSN in the manager table is tied to the manager SSN in the department table. So with a primary key to foreign key relationship, that starts to tie together all these separate pieces of data. So once again, we have this being, oh, that's not drawing my screen, is it? There we go. Okay, so once again we have the primary key being tied, which is department number, being tied to a foreign key. Okay, so that's really how all those pieces are tied together, through primary keys to foreign keys. Now a table can go ahead and have a primary key that is not attached to any other foreign key, and this first table is an example of that. Okay, now typically you probably have a project number, and you probably have other tables over here associated with that project number. So you probably in reality do, but you don't have to have a primary key tied to a foreign key. Okay, so remember again, that's really important. That primary key to foreign key relationship is actually what ties the parts together, and that's how you create queries, is tying the parts together so that this piece of data can be tied to this piece of data. Okay, now also in the next table, this is what in your database course, the Clearwater Traders database looks like. And if you take a look at this, you have a primary key tied to a foreign key. You have a primary key here tied to a foreign key. A primary tied to a foreign key here. So throughout this entire database, you have all the parts, all the tables tied together using a primary key to foreign key relationship. Sometimes we have a composite key, which are two foreign keys tied together in a particular table. Regardless, the two together make a primary key. So you always have a primary key within each separate table. And these are all separate tables, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, within the Clearwater Traders database. Okay, so and they each have specific information in them. And it solves a redundancy issue, because all of your customer data goes here. Remember the traditional database? You would have a database, but you would have customer information in each single one of those. That would be unique. In this case, you only have one place for that information, and you can see that here really well. The next slide are advantages of the database approach, and that's again using that relational database. So, and I'll just take a look at these. We've talked about a little bit before, reduced data redundancy. So you only have one set of information in one place. Now let's look at this though. Redundancies. So what you're going to say right away is that there's redundancy. CID and CID, they're the same numbers. Well, they have to be the same numbers. But if you try to minimize that redundancy, that's what's really important. This is only probably a 10-digit number and tied to a 10-digit number. If you had redundancy with the last name, first name, and address, and so on, you end up with a lot more characters that become redundant. So yes, you have minimal redundancy, but you have to have that in order to tie the pieces together. Let's see, improved data integrity, easier modification and updating, data and program independence, better access to data and information. Now, standardization of data access, because you access it from one point basically. Better overall protection of the data. If somebody can only get in from one point, one door, then you can guard that door really well. The next slide, disadvantages of the database approach. Well, it is way more complex. All your eggs are in one basket. There's no doubt about that. But with that being said, though, that you can again protect it really well and watch out for it very, very well. More difficult to recover from a failure. Yeah, your eggs are in a basket, all in one basket, so if you trip and fall, they're all going to crack. Well, you just have to take safeguards against that with backups and build redundancy into your system. And definitely it's more expensive. So again, these are big enterprise applications, and they don't come cheap. And there are very few vendors typically within each particular market that build these kinds of applications. So they're pretty pricey, but on the other hand, they do the complete job, the whole job of the entire company. Finally, what we have is distributed databases. Now, this is a database in which data is spread across several smaller databases connected via telecommunications devices. Well, and what you see, if you take a look at our student information system, when you register for classes, oftentimes, where do you register? Well, oftentimes from home. Now, you can register from school too, but oftentimes from home. So you can access that database remotely through telecommunications devices. Okay, and that's really an example of a distributed database. Not completely, but that's good enough for our purposes. Okay, so that will complete Chapter 3, talking about databases. You'll have to go on and work through get into Access and work through the problem, build a database, and we'll just go from there. Okay. So again, thank you very much, and have a good evening.